I'm Krishna. I'm having 10 years of industrial experience working for a global MNCs. So before we start today, right, I would like to introduce few folks as being joined today from today onwards. They're explicitly from, they want to carry forward from now. So it's going to be, they'll be with us from now onwards. And today we are going to start a Snowflake. Okay. So as we know, what is an agenda? Okay. So so today we are going to start with a Snowflake and we will be learning like an introduction about a Snowflake. What is a Snowflake? How it is going to be used? What are all the industries are using this Snowflake? And what exactly this Snowflake or a Snowflake cloud data warehouse is going to help you in real-time projects. Okay. So we will go through these details. Okay. So before that, okay, what I need is, so we have discussed a few concepts about a cloud, right? So what is a cloud and on-premises? So what is meant by an on-prem and what is meant by cloud?
Which runs on local machines
Okay, so it runs on what will run on local machines?
on-prem.
Okay, on-prem means runs on a local machines. Okay, okay.
Need maintenance,
Need
installation.
maintenance. Yeah, installations. Okay. What else?
You have
Can
more
be
capital
accessible.
expenses. CapEx is more on-prem.
Capex is more. Okay. Capex is nothing but a hardware. So whatever you're going to buy, your hardware commodity is there, right? Whatever the money you spend on that one is nothing but a capex. Whatever you are running the projects, that is called as an OPEX, which is an operational cost. Okay. Nothing new. This is just a capital expenditure. Okay. Yeah. What else is needed on on-premise?
Limited accessibility.
Limited accessibility. Limited accessibility. So what do you mean by limited accessibility?
Means outside the organization you cannot access the data.
You can access it, so if it's via wires and all you can pass it, but I would say limited in
But
limited.
when compared to cloud, it's limited, no?
Yeah, exactly. So every corner, so cloud, we say that for every corner from every continent, so you could able to access a cloud. So when you are into on premises, yes, you have a concise that limitations over there. Okay, so let's call it as a limited accessibility only. Okay, what else?
Cost efficient.
Cost efficient. Okay, so what way it is a cost efficient?
Not flexible enough to change with demand and
Yeah, exactly. Not flexible enough, not flexible enough to change when the demand grows, right? Or based on a demand, it is not so flexible for
Not
us to increase.
scalable.
Yeah, scalable demand grows. Okay. So yeah, same thing, right? So now this is all like, yeah,
There
go
will
ahead.
be no new updates.
New updates. There will be no new
No
update
new, yeah, no new updates.
unless you are,
Updating it,
yeah, you are
patching it.
installing it
Yeah.
or upgrading it. Okay, which is a time taking process. Okay, okay, these are all is there. Okay, I'll just take, this is the one important point to be talked about. Okay, so we have a lot of folks here, right? So a lot of experienced people here. Okay, let's take a database is there. Okay, I'm going to call it as an Oracle database. Okay, I want to upgrade this database from 8x, okay, 8x core somewhere, I would say racks, core racks to 16x, because I'm going to get a lot of data. My company has released a product and that has a super hit for me. And I started getting a lot of customer base. A lot of customers have started, joining my company and looking for that product for them. Okay. So to store that all kind of sales information, transactional information, maintenance information, how the exchange of communication is happening between the companies. Okay. So I want to store all the data. So I'm using it as an Oracle one thing. Okay. So in this Oracle, I'm currently using 8x core racks to store the data. So now I want to increase it into 16x core racks. Okay. So what are all the things I need to take care? If it is in an on-premise, how much time it can take? What is the first step we will be doing when we have a plan like this? So what happened now? The demand got grows. Okay. There is a high demand is there. Now, as per the demand, there is a data also is getting generated. Okay. So we want to store this data somewhere in the databases that we choose to have it on a Oracle on-premises. Okay. So 8x is not going to be sufficient because my customer base is increased. My developers, my testers, my analysts, so everyone got increased to serve these customers. Okay. So what happened is, as the data is very huge, whatever the racks I have, racks is nothing but a storage units. Whatever the storage units and processing units are there. Okay. So whenever racks are there, so let's think it is like a compute plus a storage. Okay, so I'll explain what is compute plus storage. Okay, so whenever you have this information, what happens is you have to, as there are number of users being increased, what happens is the storage has to be increased for you and compute has to be increased, because there are hundreds of people are parallelly accessing this Oracle to get the information to either performing in analytics or running some business for us. Okay, so now company has decided saying that, okay, this is not sufficient for us because there is a huge data. As of now, we couldn't able to store all the data in this particular unit, and also whenever there is a processing happening, it is becoming very slow. Okay, now they took a decision, okay, let's spend some money. Okay, including capex. After the capex, opex also, they've been, opex is nothing but an operational cost. Okay, so where they want to spend this much money, so they have a plan now. Okay, so now what and all they will be taking care. Okay, think that it's a local data center or a local servers your company is maintaining. Okay, so what are the things you will be taking care? What can hits your mind that what are all the things is be taken care by the company here? What things can be taken care? So example, you are doing this task. Okay, so now you want to increase this into 16 core racks. Okay, so what you will be doing, first thing you will be doing is a planning. Okay, what is the planning? There is an existing servers, existing storage which is already been running now. Okay, the company is already started utilizing it and it is running for many years. Okay, now they wants to increase it into 16 core X. Okay, so 16 core X, first thing is what they need to do is planning. The planning is done. 16 core X, they have done it. Second thing is they want to see whether what is this 16 core X is nothing but a physically they will be buying in a servers, right? Physically they will go and buy in a hard disk kind of disks. Okay, they will buying a wires. They will be expanding their data center. They will be doing all this physical hard commodity. They will be buying it. Okay, that means they will be buying emissions, they will be buying a wires, they will be buying everything from a market, they will bring it up. Okay. So and then what will happen? Engineers. Okay. These engineers are who have to fix all this kind of physical stuff. Okay. They have to fix it, and which is a time taking process. Okay. So and then what they need to do it, once fixed it, and they have to plan. Now the existing 8x can be changed as 16x. That's not possible. Okay, so what do you need to do is they have to start building it in a 16x. Okay, and make sure all the wiring and it is availability, accessibility, everything is been successfully completed and it is ready to be used. Okay, when they are performing this particular task. Okay, so what there will be a little hamper will happening to on this particular one, because they might bring it down. Okay, so they bring it down the existing. Okay, bringing down the existing servers. Okay, and accommodate the new servers with the existing one. Okay, they're expanding the services here, they're expanding the memory and expanding the compute here. Okay, to do that they have to bring down that particular existing servers. Okay, once they've been implemented everything, what happens, they have to start maintaining it. So now the maintenance got increased. 8x was being looking after by a 4 people, now 16x has to be looked by as at least a 5 people, one person at least needs to be added to it, because it's a huge data center. Now more people needed, more power is needed to it. Okay, a lot of people has to be look at that what exactly is happening in the data center. Okay, and what happen is they have to do the cost effective cost planning also for this. Okay, so do you think that how much time this all particular things will be taking, will be completed to increase from 8x to 16x? What is your rough estimation? Okay, they have a plan of increasing database sizes. Okay, both computer and storage. They wants to increase it from an 8x to 16x racks. Okay, and this is all the plan they have to implement it. Okay, so what is your approximate time it takes? Okay, for a simple example, right? Simple example, you are using a laptop. Okay, you have a plan to change your hard disk to 1 TB, which is you are using currently a 500 GB or something you're using, you want to change it to 1 TB. How much time it takes? What are the things you will be taking care?
Old data first.
Okay, old data. So you'll take a backup of something like that.
Yeah.
Okay. How much time it takes to change your laptop hard disk?
Yeah. Probably 15 minutes.
15 minutes if you have it handy and you know it's better. Okay,
Yeah.
you know perfectly it
If
is
it
better.
is compatible.
Yeah, if it is compatible. So For that, you need a plan. So you need a plan whether your laptop is compatible really with the hard disk 1 TB, it can really take up with your process and all. Okay. And is it laptop is really a feasible to change this one? So by means 99% of people of us doesn't know how to change a hard disk directly on the system. So we will be going to the laptop center and we will be asking him, we will be paying him 1 TB, we'll be buying the disk and he will be fixing all this stuff is going to take a 1 day for you automatic. Okay. Now a person says that, okay, you don't get increase anything. Okay, I'll give you in a one, probably within a 1 minute, I'll give you whatever you need it. Okay, within a 1 minute or less than a 1 minute, I'll give you whatever you need it. Okay, so you don't need to spend any of this money anywhere. Okay, don't waste a time of coming up with an infrastructure that is called a hard disk implementation or maintenance out of it. Okay, planning out of it. So you don't need all this stuff. What I'll do is I'll give you whatever the compute you need it, storage you need it at any minute, at any point in time you need it, right? You just ask me that I'll provide that one, or it is already available, you start using it. Okay, in a similar fashion, this databases, right, to perform these tasks back in probably a half a decade back. So people used to plan like this. Okay, so increasing the racks. Okay, so what happens is this all takes almost in a month. Okay, approximately it takes a month to complete this all things, buying an hardware from outside, fixing it, and make sure it is available for all the developers and all the networks over networks and all, and maintenance, cost planning. This all takes in 1 month. Okay, now cloud says, okay, whatever you're doing is something I'll give you in a minute. Okay, and also you have to do, you have to pay as you go. Okay, the model called pay as you go. Okay, use whatever you need it and pay only for what you used. Okay, example, what happened is the company has predicted similar way, company has predicted they need an 8, they are into an 8x, they are releasing a new product, they assume that product is going to change their upside down. Okay, and they thought like this is the thing they needed 16x. They have spent almost $1 million. Okay, $1 million to get this whole hardware and fix it. Okay, they release the product in the market. Okay, but unfortunately their competitor has been done it very good way. Probably he came later, or probably he done it very good way, they did the expected market customer base, he didn't get it. Okay, so he thought he will get a 1 billion customers. Okay, but he got only half a billion customers. Problem one. So what happened is when the problem one happens, the half a million he got it, so that means he actually should have been set up only half million over the here for in all the infrastructure, but he wasted another half a million because he couldn't able to predict it. He predicted that prediction went wrong, right? So as the prediction went wrong, there is a huge loss for the company here. Okay, so prediction went wrong. Because of that, your unnecessary cost has been increased. Okay, increased. Okay, due to this, the company went into loss. Now the resolution to the cloud is says that utilize what, okay, infra and storage you need it. Okay, you need it. So he will say that it will be available within a fraction of minutes for you. Okay, problem two. Okay, so in a similar fashion, what happened is he thought there will be in a 1 billion customer comes in, but what happened is he really got a 1.5 billion. Okay, now the problem is circled out. What happened is the estimation, more than estimation, he got a 1.5 billion, but his hardware, whatever the the planning he has done, the 16 is not sufficient for him now. Okay, so he wants to go more. Probably he has to go for the 24 now. Okay, so in that case, what he need to do, he has to replan everything again now. Okay, which is going to take you almost 1 month again. Okay, or after a 1 month he got this customer base, that customer base might get reduced again. Anything can happen. Okay, in that case he has to spend a lot of time again. If a prediction went wrong again here, but this time he got a more customer base. Okay, in that cases again the same thing is valid. Your prediction is wrong. Unnecessary, instead of unnecessary cost, the infrastructure cost you are being predicted is not sufficient for you. Again there is a problem. Okay, now the cloud says that same thing, infra and storage, everything is available in a fraction of minutes with me, so you can use it. Okay, here cost saving. In first case he wasted a money, in second case he has to spend a more money again now. Okay, now cloud says that, right? Okay, infra is going to give within a fraction of minutes. Services, you don't need to maintain anything. Okay, everything will be maintained by a cloud. Okay, and also whatever your demand is right now, that means right now I need a 10 GB of data to store it, and I need a compute servers is a 10 servers I need it. Okay, so use only that much and pay only that much. Okay, you don't need to pay more than that. So for, I would say, till today you used 40 GB of a space to store information, and compute you have used almost like in a 10 CPUs. Okay, you pay only for this much. Okay, this model called as a pay as you go model. Okay, pay as you go model. Okay, so now companies, what they do is unnecessarily investing time and money on this whole infrastructure. They will be moving towards a cloud to utilize the existing infrastructure and start building an applications on top of it. Okay, to save a lot of money, right? Prediction, so infrastructure, maintaining this. So how this will happen, company will be maintaining a physical locations. That physical locations, connections, NAS, everything, they have to check it up, and the company people has to maintain it, which is going to be a very hectic task for them, right? So now cloud is saying, way on a very, very easy way, I will be providing all this information, all this infrastructure and everything for you. All you need to do is concentrate on your business, building an applications and communicating and providing your services to the companies. Okay, so which model it is going to use it? It is going to use as a pay as you go model. So you don't need to spend more money over here. You don't need to waste money of spending more at a upfront itself. Okay, so major issue being resolved here. Okay, so now, right, in a cloud we have an IaaS, okay, PaaS, and SaaS. Okay, so major factors are there. Okay, one is IaaS, right? Is nothing but an infrastructure as a service. Okay, PaaS, which is a platform as a service. Okay, SaaS is nothing but a software as a service. Okay, so what is this means is IaaS is called as an infrastructure as a service. What here they will do is they'll provide all the infrastructure for you. That means they will make sure the servers are there. There is a storage locations are there. You know, load balancers are there. They will provide everything for you. All you need to do is you have to start building your application on top of it. Okay, so you have to maintain your security. You have to maintain your infrastructure. You have to maintain all the stuffs. Okay, so platform, so I don't go more in detail of this one, we will discuss when we are discussing a cloud. So I want to highlight that Snowflake is a SaaS, which is a software as a service. Okay, so as it is a software as a service, no installation is needed for you. Okay, you can access this. Okay, you can access Snowflake via internet. Okay, so that is no installation needed on your laptop. Okay, no maintenance is needed on your laptop, no space is needed on your laptop, no hard disk, nothing to do with your laptop. Okay, nothing to do with your particular missions. There is no VDAs also needed for it. All you need it is a simple internet. Okay, all you need is in a simple internet. So no installation, no maintenance. Okay, you don't need any physical laptops or anything from here. Okay, so and it is a software as a service. Snowflake is providing us as a software as service, which is fully built a solution already is been available. You can access it via internet. Okay, I'll quickly take a question. Okay, so I have observed that the time SaaS could architect is different and upper limit by company. Hosting services, not AWS, restrict usage, execution time, how much memory occupied, etc. How to manage these things. So, Samir, I have observed that at times SaaS cloud architecture is different and upper limit by company hosting services. Okay. That restricts usage like execution time, how much memory occupied, etc. How to manage these things. So, Samir, so what happens is this is all nothing to be managed from your end. Okay, so there is nothing we will be provisioning in an architecture, or we will be provisioning any software on the on a internet. Okay, so what happens here it is, you are not sure either what so what we'll do is Snowflake is a cloud agnostic solution to your question I'm saying. Okay, cloud agnostic solution, that means Snowflake can able to connect with all the public clouds. Okay, I mean to say famous public clouds, which are all AWS, okay, GCP, and Azure. Okay, so what happens is when you are choosing an account, your Snowflake account, okay, Snowflake account will work on top of any of your public clouds. Okay. While you're creating a Snowflake account, if you choose out any out of this one, so either it is an AWS, GCP, or an Azure. Okay. It's not mandate always should be an AWS or something like this. Okay. So what happens is whatever the time taking or whatever the latency is, how the architecting happens on top of it, the particular layers is nothing you need to maintain from here. Okay. So what happens is on top of this, Snowflake will able to maintain everything for you in even provisioning of an infrastructure, optimizing of a solutions, encryptions and decryptions, even at a runtime, or as I would say, at a motion, right? So when the data is coming out of the table and going into the tables or going into the databases, both will be encrypted and looking after by a Snowflake. Okay. So there is nothing you to maintain anything. Okay. So to your question, one more point you mentioned here, execution time, okay, and memory occupied by this extra, right? So this all will be taken care by Snowflake. How they will maintain is they have created their own templates in the backend. Okay, so those templates also you will not able to say it. So what happen is based on the level of you're going to design your warehouse. Okay, we'll come up with that concept based on the warehouse you are going to design. Okay, in a Snowflake, what warehouse you are going to use it, based on that Snowflake will able to provision that particular architecture. Okay, provision that infrastructure, architecture and all, they have already templates created. Okay, so what will happen is that automatically will be onboarded when you are trying to run something. Okay, so they will be taking care of your execution time. So now your execution time is needed more. Okay, they will be giving upfront in warehouses. They will say that we have a small warehouse. They will be calling it a t-shirt size. Okay, small, large, medium. So like that, there will be etc. Many are there. Okay, so what happens is based on the warehouse you are choosing to run your particular application or processing. Okay, so the templates will get activated on particular accounts. Okay, it could be an AWS, Azure, or a GCP. On those accounts, the templates will get created and the infrastructure will make it available within a fraction of seconds. Okay, so that particular warehouse will define that how much execution time you are going to use it, how much memory is needed it, how much CPUs are needed it, what kind of what kind of software to be installed on top of it. Example like an OS. Okay, whenever there is a servers are created, there is a OS to be created, right? So those servers, OS and everything will be defined by a Snowflake. So there is nothing you need to take care anything over here. So infra side, there is nothing. It's a software as a service, which is a readily available solution. All you need to do is you have to having an internet and start using that warehouse, start using that software for your application purpose. Okay. Samit, did I make sense? Okay. Yeah. So yeah. So coming to the Snowflake, right? So we said Snowflake is a SaaS. Okay. So first question and very important question for any certifications also. Snowflake is a SaaS, which is a software as a service. Okay. So next one is no installation, no maintenance, no hardware, nothing is needed for it because we are going to access it via internet. Okay. So, and next one, internet, and it's a cloud agnostic solution, which means you are going to have it on any famous public clouds. Okay, that is in AWS, GCP, and Azure. The first design was happened the Snowflake within AWS. Okay, first they have came up with all the features and every implementation happened on AWS. Then only they started implementing on a GCP and Azure because AWS was there in the market from a almost 2010. Okay, 2008 is officially they started, 2010 is where it got famous. Okay, from 2012 Snowflake has been tied up with an AWS teams and they started building the features for us. Okay, 2012 they have came into the market Snowflake. 2014 onwards they started selling the product to the companies. Okay, so let's go here, little more details I will be explaining here. Okay, so let me quickly go here. You guys able to see my screen?
Krishna, before we go to this cloud data warehouse, right? Will you be covering the data warehousing basics actually regarding the the different type of schemas are there, right? Star schema and Snowflake schema,
Yeah,
and also
we will
the
as part
fact
of.
table, dimension table. That are all the basics of data warehousing, right?
Yeah, so while implementing, right, in Snowflake, what we'll do is while implementing that, we will be discussing about facts and dimensions. We'll discuss very quickly now itself. That probably once we start with an applications, okay, while building it, Snowflake schema and star schema, we will be discussing in another topic. Those were being covered as part of this. Okay, we'll cover
Okay.
that. So now we will
Okay.
understand the architecture, how it works. Okay. And the models, those are models, right? So it's not actually a data warehouse is how it should be. It's not mandatory always you should follow a facts and dimensions, or you have to follow a Snowflake schema or a star schemas. Okay. It's not mandate. It's a good models to be followed for your applications, but it is mandate for the data engineers to understand also. So while we implementing, we will start building the fact models and dimension models so that you will understand easily. Okay. So if I explain it theoretically, there is no confusion.
Okay, Krishna, thank you.
Any other questions? Okay. So I take that as no questions. So you see on the right hand side, right? This is a Snowflake architecture, which is a 3-layered architecture. Okay. So we call it as a multi-cluster shared data architecture. So why multi-clustered? Okay. So what is clustered? Anybody can say what is cluster?
Group of servers.
Group.
A group of servers. Okay. Okay. A group of servers. What else you can able to call?
Nodes, multi-nodes.
Multi-nodes, multi-missions, so everything, right? So where your work is shared between a different servers. Okay. So what happens is the work is distributed between its clusters and make sure the data is the particular request is being distributed to multiple clusters to make sure the data, the processing of your question or the request is going to be in a faster way. Okay. So here also when we go into a Snowflake, what happens is we will be dealing with the multi-clustered architectures. Okay. So we will be dealing with multi-cluster. Okay. And single clusters as well. Single clusters and multi clusters both are available, and what cases we have to use a single clusters and what cases we have to use a multi clusters will be using. Okay. But here why we call it as a multi cluster is Snowflake can able to accommodate your multi clusters as well. If you think that you have a very important processing should be done, there are some queries or there are some applications are running now, and thus applications needed a warehouses. Okay. In a distributed fashion and very fast it should be completed. Okay, in that cases, Snowflake is going to help you to onboard your multi-clusters. How it needs to be created via command and via UI, we will see that. Okay, so now this is a 3-layered architecture, which you see on this one, multi-servers joined as a provider a shared service platform. Yeah. So now 3 layers, right? So this 3 layer, the first layer, call it as in a cloud services layer. Okay, which is also called as in a metadata layer. Okay. So cloud services layer or a metadata layer, anything you can call it. Okay. Second layer is called as in a compute resource layer or virtual warehouse layer. Okay. So people will be calling with a fancy names, but the meaning of that is going to be same. Okay. So we will understand why they are calling with that names. Final layer is called as a storage resources where your actual data is going to be stored. Okay, so first one I'm calling it as in a metadata layer or a cloud services layer. The first layer, whatever the box you're going to see it, right? This will be automatic. This is totally will be maintained by a Snowflake. Okay, so you don't need to worry about an authentication and an access control. Once you're logging in, maintaining the credentials, authentications, everything will be maintained by your Snowflake for you. So there is no need of sorry. Is there anything to check, Kanna? Okay, sorry, yeah. So what will happen is everything will maintained by a Snowflake for you. Okay, starting from an authentication and access controls. So once you are being done your access controls roles and all, if you have created, how it needs to be maintained, so how it where exactly it is stored, so that all will be taken care by a cloud services. That is Snowflake layer. Okay, infrastructure manager, that means warehouses availability, says that now I need I have a query to run it. Okay, I need some server to needed for that. Okay, so example, I need 10 CPU is needed for it. Okay, so what happens, the 10 CPU provisioning, you don't need to write any code over here. Okay, says that at this particular point in time I need this particular server to be executed. You don't need that. Okay, so what you need to do is you simply design your warehouse and you call that warehouse saying that okay, this is the warehouse I'm going to use to run these queries. Whenever this warehouse is get activated for you, right? So what happens is automatically Snowflake understands saying that Krishna wants to run some queries with this warehouse. Whatever the backend infrastructure being designed for that warehouse, okay, what you need to do is you start implementing on the account he has chosen. Okay, either it is in AWS, either it is in Azure, either it is in a GCP. Okay, and optimizer. So what is optimizer? So optimizer is something that, so anybody knows what is an explain plan?
It will give details about the access path chosen by the database.
Access table. Okay. Okay. Anybody wants to explain more?
will explain about the query process in the backend.
Okay, perfect. So query processing in sense, so what are the table, where exactly the high time it is going to take it, how much data you are going to read it, how much time it takes to run the query for at that particular point in time. Okay. Explain plan will give you a detailed information of the query you are going to execute. Okay. So based on that information, what is the explain plan is going to do it. So you could able to understand where exactly you're putting more pressure on particular tables to read the data or something. Okay. In a similar fashion, optimizer also works in a backend to optimize the infrastructure. Okay. So it could be an optimization happen saying that this particular query based on the explain plan doesn't need all the resources to be available. Okay. Or all the warehouses, full warehouse is not available. So 10 CPUs, our example, auto scaling is needed. Okay. So it's that kind of decisions, how much space is needed, how much servers is needed, how to optimize this query. Okay. So what happens is internally Snowflake optimizes whatever the request you've been sent, and based on that optimized query, so it will request for the resources needed for it. Okay. It's not like you have fired a query and you are reading a 10 tables. In that 10 table needs one Excel cluster to be executed. Okay. So it will not put any, so it's not like it will not put any intelligence and directly ask for that cluster and make you cost you a lot of money for it. Okay. So what optimizer will do is, so in simple terms, right? So what happen is you have written a query. Okay. I'm just giving a simple query. In this, there are 10 tables are available. Okay. So ideally 10 tables are holding, each table is holding 1 or 10 million records. Okay. 10 million records. So what happens here it is, so this 10 million records, right? So ideally, if you run similarly on your on-premises, what will happen is all the tables will get scanned. Okay. And then start distributing the data between their whatever the service is available in an on-premises. Okay. There is no optimization happens over here. Okay. There is no optimization happen over here. What happens when you comes to a Snowflake, right? They put an intelligence in a backend. So they will understand whether this table's been encrypted or compressed. Okay. Or while you're reading the data, when it comes to in-memory, compress that in-memory intermediate results. Okay. So for every table, the data needs to be read, right? So that means there is an intermediate results. Okay. This intermediate results will come into an in-memory. Okay. They will start I'm just giving an example how query works, but this optimizer will work in a way for the infrastructure also. Okay. So what it will decide is it decides saying that optimize the request and see how much really the infra is needed for that particular query. Okay. So as they are doing this optimization, you see here, they are doing an automatic optimization, which they are taking out the headache of the developer over here. Okay. So they are optimizing for us and they will be giving the particular resources needed for that particular queries or the request you're going to do it. Okay. So let me quickly take a question. So any particular info which partition a query should touch or an idle execution if you use more data retrieval. Karthik, any particular info about which partition a query should touch or idle execution if you use more data? So yes, we will be, so instead of you say which partition you need it, so when you say clustering the data, how it is going to organize the data internally, okay, and it happens. So I would say this is one way correct, okay. Yeah, this is one way correct. It's a one way correct, but there isn't a more expansion to it, so that we will discuss how the micro partitions will work it. Okay. Snowflake tables. Yes, Karthik, that's correct. Whatever you're saying. Okay. So if you are asking a question, okay, so that's how it partitions the tables. Okay. So we will discuss that partitions, advantage of a partition and disadvantages of the partitions also we'll discuss. Okay. Okay. So data optimized. So Snowflake, what happens is it optimizes whatever the request. It's not like blindly whatever you queried, it will send it to the servers and make it execute. In between, there is a layer called as an optimization. The optimizer will understand what is your request. It optimizes. As it is optimizing, which is going to cost you $10 without optimization, it might reduce it to the $9 and $8 cost for you. Okay. So Snowflake have that kind of optimization also at a metadata layers. Okay. So can we modify this optimizer to do it in a better way, or we want to understand? So there is nothing. As I said, first layer will be totally maintained by a Snowflake, which is a hidden layer for us. Everything will be maintained by a Snowflake for us. Okay. Transaction manager is nothing but a request and a response. Okay. So there is a request happening. So example, I would say I have loaded a data into a particular table. Okay. There is a transaction being done. So about that particular transaction, I want to have that information somewhere. So example now, let's take Karthik has loaded 100 tables. Okay, Karthik loaded 100 tables. Okay, each table is holding 100 records something. At what time Karthik has loaded? Okay, from where exactly he read the data? What are the code he has used? What query he has used? At what particular timestamp he has loaded the data? What warehouse he used to load the data? How much time that query been loaded the data? Okay, so about a transaction, every information, every inch of an information. That means now how much warehouse. So example, how much warehouse? A warehouse is having a 10 clusters. Okay, how much each cluster is costed for us. Okay, so you will be having every bit of information of the transactions you are going to do it. Okay, so who is maintaining? You don't need to design anything to capture this one. Okay, Snowflake has already built all these algorithms and they will be maintaining this information in a called in a a tables called as schema called as an information schema. Under this information schema, they will be taking all the metadata. Okay, so when I say metadata, it could be anything. You created a table, you dropped a table, you loaded a table, you executed a query, how much time you executed, what warehouse you have been used, what masking policies you've been implemented. So everything. Okay, every bit of transaction you're going to make it on a Snowflake, they will be maintaining it for you. Okay, how much time it has to be maintained. Okay, so that also you can able to decide it. Okay, what kind of editions? So Snowflake provides a different editions for us. So based on the edition to edition, it will be decided how much time you are going to save that information. Okay, so how this information, right? So what I'm saying is this transaction manager, what is the benefits of this transaction manager you think of? Okay, this transaction manager, what is the benefits of this transaction manager? Now I said that it captures everything. Whatever you do, Karthik does whatever, Soumya whatever she done, so whoever does whatever the activities, it is going to capture that information. For what purposes this particular information will help us, and what kind of things which can be aligned using this data? Use cases.
If we deleted any data, that can be
So
retrieved
you
back.
can identify people who has accessed that particular table last and made a deletion on happened it. So we can talk to that person why you have deleted the data. One thing, good idea. What else?
For auditing purposes.
For auditing purposes, very nice. Yeah, auditing, performance management, recovery management. Yes. What else? Auditing purpose is one major thing, right? So we want to see who are all accessing a sensitive data. Is anybody has downloaded the data? Is anybody has executed queries on that particular table? Or exactly, so one more problem is something, some people what they do is they will run the query using a warehouse. Okay, and they will go and sleep. Okay, that query will be keep running. Okay, they would have written a very bad query and it is running for a keep running. So as we say, what is a cloud model? As how much time you are going to run, that much money you are going to pay. Okay, because this is a cloud model, right? So cloud model, what happens is you keep running, your billing will be keep increasing there. Okay, now I need to identify which query has been executed more than 4 hours. I want to talk to those people why they are doing it. Okay, if what I need to do is, yes, there are people doing like this. So now what I need to do is I need to make any query should not execute more than 15 minutes. Okay, if I want to set that kind of barriers, where you'll find that kind of information, your transaction manager is going to help you. Okay, so you will have a plenty of use cases when you are going within an information schema that we will be learning. Very important to understand the information schema. Okay, so next box you can see it is a security. Okay, security at motion at rest. That means when the data is going out of a Snowflake or the data which is entering into Snowflake, so every place it is going to be in an encrypted way. Okay, data is almost so at every location it is an encrypted. The key managed systems will be maintained by a Snowflake. Okay, so when you go into a Snowflake, so when you go into in a different cloud areas, Azure or some places, right? So what happens? They also use key managed systems. Okay, so either it is a client server side, so client side key managed systems, or it is in a directly they are supplying it, whatever the cloud services they are going to provide a key managed systems for us. Okay, security, what happens is to maintain the data, to make sure no one else unorganized, so unauthorized persons are not supposed to access this data. Okay, to do this security, so Snowflake also maintains a key managed systems, so they will maintaining it. So Snowflake make sure they are doing a rekeying also. Okay, that means once you apply a key, they will be they will be flushing out that keys very frequently, and they will be rekeying that one with the new keys. They will be encrypting the data to make sure that no one If someone have the old key, what happens is they cannot able to access the new data. Okay, so they will make sure more and more security being implemented, so that algorithms you don't need to implement anything from your end. Okay, everything will be handled by a Snowflake. Okay, so let me take this question. There are different layers in the clouds are all handled by a data engineer, like the infrastructure manager, transaction manager, or those are just concepts. So yes, so this infrastructure, these are concepts, Soumya. So what happens is data engineers will not maintain infrastructure managers. Okay, transactions all will be done by a data engineers. Okay, so but what happens is generally when you go into on premises versus something, so what happens is if someone has deleted some data in a particular table, it is very hard to find it for you to understand. Okay, they also maintain, but you have to write your own algorithm to store that kind of data. Okay, there is a major headache for you to maintain that kind of data by your, usually what happens is not developers, data admins will be writing that logics, and they will be storing it into your different tables. So when you comes to your Snowflake, what they are doing is you don't need an extra people to do that activities. What we are doing is we are going to provide you as an additional services. Okay, so you don't need a different people hire, you don't need to hire a people to do that kind of activities. I'm already providing that services for you. Okay, does that make sense, Soumya? Okay.
Okay, so these are the services provided by Snowflake.
Yes, it is directly providing by a Snowflake. So the first layer, the cloud services layer, right, which is all maintained by a Snowflake for you. Okay.
Okay.
So usually if not Snowflake, what we need to do is we have to, as a developers or a data admins, DB admins, we will be calling it database admins. They have to take care of all this stuff. Okay. Now Snowflake says that we don't need to have those people. So I will be maintaining all this stuff for you. Okay, as in a value added services when you take an agreement with me. Okay, they say it's a value added services, but there will be a cost for this also behind. So they say that as it is a software as a service, this must cost, it will be included in that cost itself. Okay, and finally metadata, right? So metadata, so it will be having all your tables informations, all your views information, stored processes informations. You create a cloned tables, you create a external stages or internal stages, whatever the artifacts you are going to create it on a Snowflake, that all information also will be stored for you. It's not like, so you have to know, so system tables, right? So usually what happens, so a lot of people you would be already knowing that if you have worked in Oracle, PostgreSQL, or wherever, the system tables will be available. Those system tables will help you to understand how many tables are there in the schema, how many views are there in the schema, who created this particular tables. So this all information will be available. The same kind of information will be available in our Snowflake also. That will be information will be available in metadata. Okay. So what happens is you don't need to have any separate tables for each thing. This guys has created nicely a backend table, Snowflake, in backend tables, which you can't see that. So on top of it, they have built the views. Okay, the calculated views they have already written. Okay, so once we log in into your Snowflake, I'll show you that how the views they have written. So using that views, you can able to calculate whatever you need it. Okay, which is a pre-calculated information which is already available for you. You can just go and write it. You don't need to do any other further calculations for it. Okay, so this all the layers, so this all the information will be available on your first layer, which is called as a metadata layer or a cloud services layer. Okay, so when we are going into caching, okay, so we will be understanding there is a 3 different types of caches available. So that caches also we will be understanding when we go into that particular class. Okay, second layer is all a virtual warehouse layer, which is nothing but a servers which will be spinning up for you whenever you request something. Okay, so you need a servers to be executed. So any query, right, either your laptop also, whenever your laptop, what happens, you requested something, if you're trying to open some application, what happened backend, there is a processor runs, executes, right? So once it is executes, it will able to open, it will support that application to be opened on your system. In a similar fashion, anywhere, right? So any application, if you want to run it, you need the backend servers to be executed for it. Okay, so in Snowflake also there is a servers, that servers called as in a virtual warehouses or compute resources we will be calling. Okay, this virtual warehouses will be helping you out to provide all your compute to execute the particular tasks. Okay, and third layer is going to be a storage resources where your actual data is going to be stored. Okay, so now the question is, so now I'm saying that Snowflake is just a software as a service, okay, which can be landed on top of any public clouds, which you see here, any public clouds. Okay, that is like either GCP, Azure, RNA, you can say GCP, Azure, or AWS, right? So I said that. So now when I'm saying this, the storage resources at a last layer is going to have your actual data. Okay, when I say actual data, whatever the transaction information, customer information, sales information, product information, whatever it could be. Okay, whatever you're trying to store the data, that data is available in the last layer. Okay, this last layer is going to store where exactly. Okay, where exactly this last layer of information is going to be stored. Okay, so what happens is, this is bit little tricky to understand, but try to understand how they have designed it in that way. Okay, so now I said that. Okay, so all your Snowflake as a software as a service. Okay, I'm coming here. Snowflake software as a service. Okay, so this is the top layer. Okay, and it uses all the public clouds to store this information or process your information. So example, I would say AWS. I've chosen an account called as an in AWS. Okay, so what Snowflake does is, Snowflake starts utilizing all the services from an AWS. Okay, Snowflake by itself doesn't have a compute. Okay, or it doesn't have a storage. Okay, there is no storage units for a Snowflake. There is no compute resources for a Snowflake. Yeah, thanks. Okay, so try to understand here, Snowflake is just a software which leverages the power or the resources which are available in the public clouds, which you are going to choose at the time of your account creations. Okay, so when you want Snowflake, on a Snowflake, now example, I would say that I'm going to run this particular query. Okay, so example, simple query. Okay, this query I want to execute with a warehouse is equals to medium. Okay, so now when I ask my Snowflake, this is what I want to run it. What Snowflake does is, the warehouse you choose, right? It will talk to this AWS resources. Okay, it will talk to the AWS resources and make sure the infrastructure. Okay, infrastructure means, so okay, the infrastructure means that is called as in a compute servers. Okay, it activate the servers to run this particular query. Okay, the customer data which is available on the storage of an AWS only. Okay, by Snowflake itself, try to understand here, by Snowflake itself doesn't have any servers for them. They don't have any storage units also. Okay, so what they do is, this guy is created a software in a way that the algorithm works. So whatever you are going to access here, okay, which will be communicated internally to the cloud accounts which you have chosen. Okay, and starts onboarding whatever the infra is needed for that particular query to execute for us. Okay, it could be GCP, it could be, sorry, it could be AWS, it could be GCP, or it could be, okay, Azure, whatever the account you choose at the time of creating your Snowflake account. Okay, so it will communicate. So that's where the software has been works. The software has as a total intelligence how it needs to communicate with this public clouds and get the data as fast as possible. How that optimizer is going to help you is the optimizing the solution, optimizing the query when you are sending to that one with less latency, very as less possible as latency. Okay, so they have a lot of things in a backend they have written, or execute, no, they have written that algorithms, so that algorithms will work in a fashion saying that communicate with any clouds and get the data as soon as possible. Or you choose this any of these accounts, their algorithm will work in a way saying that how can they nicely fit in here. Okay, and also Snowflake, if you have onboarded your Snowflake account using an AWS, it doesn't mean you cannot access a GCP or an Azure. You can still able to access your GCP or Azure accounts also. You can integrate your GCP and Azure also into your Snowflake. Okay, that's the reason we call it as a cloud-agnostic solution. It's not like at any point in time, it's not tagged to a one single cloud. It can be tagged to any clouds. Okay, just understand when someone says that where exactly your data will be stored in a Snowflake. There is no data centers, there is no storage units for a Snowflake. Okay, Snowflake uses the public clouds which you have choose at the time of account creation. All your data will get stored in that particular public clouds. Okay, so it leverages all the infrastructure. How it is going to provision, how it is going to leverage is something we will never going to get it. So because that algorithm, that software being designed by a Snowflake. Okay, So whatever you're going to do, whatever you're going to choose it, they make sure the templates, everything what they have written is been modulated to communicate with that particular cloud service and get your work done. Okay. So I'll just quickly take a question. What if the data center fails? So Karthik, cloud, right? So let me tell that. Usually I'll tell when we go into cloud. Okay. So what happens is clouds, right? So usually when you go into cloud, there will be a different availability zones and different reasons. Okay. So our example, India, right? In India, so what happens is within India, we have AWS, example, take AWS. Okay. So we have it in Hyderabad. Okay. One is in Mumbai and one is in Mumbai and one is in Delhi, I believe, not Delhi, or somewhere in South India only, somewhere it is there. Okay. Let's take it as a Chennai. Okay. So what happens is India is a reason for you. Okay. India is a reason for you. Let me go here. This is a reason for you. And these are all called availability zones. Okay, ASA. Okay, availability zones. In case if one of this, so always what happens is there will be a backup data will be available in a day. So now example, you choose in Hyderabad. Okay, you choose to have your data in Hyderabad, and what happens is automatically it will be taken backup in one out of this. Okay, or in a two. You can choose it how many you have to replicate and take a backups. Okay, one is something mandatorily will be available. Okay, you need a more backups, you can take a more backups. Okay, you need a multi reason, I want to take a backup in US and India. Okay, you can choose for the multi reason as well. Okay, so based on that, in case of any data center, example, think that Chennai any floods happened or any disaster happened, so your data center is gone, then what will happen is cloud designed in a backend via DNS and CDNs. What they do is they will route that particular example, this query I'm executing. Okay, my office is in Chennai and I choose my main availability zone is from Chennai. So when I executed this query, it will bring me the data from a Chennai data center and it will bring me data from there. Okay, in case this data Chennai data is been gone, this data center is gone, right? So what happens is for every availability zones there will be a disaster recovery zones. Okay, which is called as a DR zones. Okay, so they will be choosing a nearby to the Chennai, that is like either a Mumbai or a Hyderabad, they will choose it and they will start replicating the data every time as a backup. Okay, in case your Chennai is gone, so this particular request will be routed to the Hyderabad. So you don't need to take any kind of, any manual changes or any configuration changes. You don't need to do anything. Automatically AWS will design in that way. So they will start routing it to the, Hyderabad, and they will brought up the data from a Hyderabad data center and make sure the data is available for you. Okay, does that make sense? Thank you. So it is replicated, but if it is integrated across AWS, GCP, Azure, it's still a high availability. Yes, your wish. So high availability, but unnecessary cost. Really, you need that different cloud accounts, different data availability at different places. How you are going to maintain it? If you think that I'm going to maintain it and I know that where all the data, if now think that there is a customer table created in a Azure Mumbai zone, GCP Hyderabad zone, and AWS in a US zone. Okay, how you are going to communicate to your developers from where you have to access it? That level of maintenance, if you are ready to do it, yes, it is high availability, right? So you don't need to go. So I would say instead of that, you can always go with okay multi-reason, right? So if India have some disaster or US have some disaster, the other country availability zone is already available for you to access it. It's not possible to have a disaster at two places. Okay. So there is a question. Snowflake is a DB or a ETL. So Snowflake is a data warehouse and it's an ELT tool also. Okay, instead of ETL is nothing but an extract, transform, and load. So it's an ELT process. What does that means? Extract, load the data into Snowflake and apply the transformations so that your process will be very fast. Because once you load the data into a Snowflake, on top of this data only you are going to transform it. That means your L and T is going to happen on same server, that is called a Snowflake server. So whatever the transformations you are going to apply on a Snowflake is going to be a very fast. Okay. It's in a data warehouse database. You can call data warehouse covers the database also. Okay. So it's a data warehouse and then it's an ELT process. We'll be doing it. Okay. Yeah. If it is an ELT, can the host my stage on source and the target best practice? Source in sense, see, Snowflake has a one more. So right by Snowflake itself, okay, it can connect to any public clouds. Okay. Any public clouds in sense, all the GCP, AWS and Azure. Okay. But it cannot connect to any on-premise. Okay. Snowflake doesn't have any feature that it can able to directly communicate to your Oracle or a MySQL or something. You need some support in between. You need some integrator in between. Okay. So to our projects, what we have designed is we have designed Python in between. Okay. Python talks to your MySQL, which we covered in a last session. Okay. Python talks to MySQL and then it will start putting a data into Snowflake. Raw data it will put on a Snowflake. Okay. In Snowflake itself, we will process it. That means you see here, E is going to happen by Python. Python is going to extract the data from MySQL and it loads the data into Snowflake as a raw data, and all the transformations, that is business rules and all, we will be applying in a Snowflake. Okay, for a faster processing. Okay. Yeah. So so is in the case where I can transfer. So it's better to do it in a Snowflake. So you'll have a better fast transformations because the data is already available, raw data, right? So do a transformation on a Snowflake so that we will see it. Okay, when we are processing it, that we'll see what are the topics that are covered for the AWS side as a training title as it. So yeah, so Harish, right? So Harish, all the data engineering concepts, right? So when you go into an AWS, we are covering, so starting from an S3, SQS SNS, Athena, Lambda functions, AWS Glue, AWS EMR, and then we are going to talk about Redshift, DynamoDB, step functions, and then cloud logging. Okay. So all these topics were going to be covered as part of the data engineering of AWS. Okay. So let me go again here. Okay. So this one, anybody have a doubt on this one? Anybody have a confusion on this one? How Snowflake works, how the infrastructure comes. Okay. So now I have a
So,
question here. Yeah, please
sorry,
go ahead.
Krishna. So, Chandra here, as we are using multiple cloud systems based on the regions, okay, will there be any impact to the applications?
Will it be?
You mean like the speed of data transfer?
Ideally not.
Mhm.
Ideally not. There won't be any. So when it will be happening is, think that your company is working in an India and you started storing a data in a Switzerland. Okay. So in that cases, you will be seeing a slight latency will be there. Okay. So it's always a best practice is wherever your company is running. So you have a nearby availability. Choosing a nearby availability zones is the best way.
So do we need to choose by ourselves? Okay,
In
stating that
Snowflake,
I'm.
yeah,
Uh,
in Snowflake, you don't need to do anything. Okay.
mhm,
So from
mhm.
where you are creating an account, the place you are going to choose it, where you are going to onboard your account. So example, while you're creating an account itself, it will ask you from which country you are doing it. So example, if I choose India or Singapore or something like that, what it does is automatically it designs in a backend which availability zone is a faster for them and where exactly it has to take the backup, how many availability zones it has to take a backup. That all things will be taken care by Snowflake.
Okay, got it.
Okay. So you don't need to do. So when we go into AWS, we will understand what are the availability zones and how you need to choose it. When you have to manually do it, how you need to choose it. Okay. Yeah.
Yeah, thank you.
So yeah, go ahead. Who was asking that question? Next one.
So what is the difference between AWS and Snowflake? Both are cloud, right?
Yeah, exactly. That's the same question I was expecting. I am about to ask that. What is the difference between AWS and Snowflake? If anybody would have understand this one, right? What is the difference between AWS and Snowflake? What you understand on this one, not to you, the question who asked, right? So not to you, question to others. What is Snowflake is doing? What is AWS is doing here?
So here, if you see, Snowflake doesn't have its own storage and it doesn't come. It's like a medium who uses AWS services for storage and other stuff.
Exactly. So what happens is Snowflake is just a software. Okay. Snowflake will not provide you any kind of infra. That means either servers or running application. So to run the application, CPUs. Example, I would say that. So this guy provides you a laptop. Okay. This guy provides you in a software. Okay. So when you run something on your, so example, you have installed some software on your system now. When you click that software and you started working on that software, okay, that software doesn't have any infrastructure. That software, that laptop is made by an AWS. AWS is going to provide you hard disk. AWS is going to provide you, motherboard, processors, whatever the CPUs has to be executed for it. So everything is going to provide by this guy. Okay. What this software is doing is this software is using that existing all the stuffs. Okay, this software is designed in a way to utilize this infrastructure and complete whatever the task is going to be done. Okay, to your question also, what happens is Snowflake is just a SaaS, which is a software as a service. It's a software. Okay, so what happens is this software have an intelligence to use any public cloud based on the based on the choice of yours. Okay, and it will able to communicate this to with this clouds. Okay, talk to these clouds and get it assigned whatever you need it. Okay, so in that case, if you have a question saying that do I need to maintain these clouds also, no, you don't need to worry anything. All you need to do is when you are creating a Snowflake account, I want to keep my data into an AWS because I believe that AWS is a more secured environment. Okay, it could be a more secured environment or a cost optimization perspective, or it is a high availability also, right? So why your question should be, how can I choose this cloud, Krishna? When I'm creating in a Snowflake, how can I choose this, which one is needed for my company? Okay, first is a cost optimization. So cost, how much cost each cloud is going to happen. Second thing is, it is not mandate all the countries, all the continents can have each and every cloud. If you go to Denmark, Sweden and all, you might not see the GCP is available there, or Azure might not be available there. AWS is available for them, but the company wants to use a cloud. Now the option they have is they have to go with an AWS. Okay, or when you go into different places, now you go to US. Okay, in some regions, Oregon or else you go to the Michigan or some places, right? What happens is infrastructure cost there, Azure might be less than your AWS, or AWS is less than Azure. Okay, so you have to choose an AWS. Or think that in some country, what happens is Azure have more availability zones. Okay, so that means more backups you can able to take it because your data is very important for you. AWS has a less availability zones. Then what is the option you will be going with? Snowflake attached within Azure. Okay, that's how your companies will be deciding. There will be multiple parameters in that. What they will do is this Snowflake, right? With this Snowflake, they say that if you are taking an agreement license with us for next 10 years, okay, so what we do is in your location, we will, so usually what companies will do is first as starting, they will be talking, your sales team will be talking to the Snowflake team, and they will be explaining their requirement, how much data they are going to storage, how frequently they are going to run it, how fast they want the data. This all they will be talking to the Snowflake team. Snowflake sales team will bring up and given a suggestions. Okay, so 10 years contract if you take us. Okay, Azure is the best in your region. Okay, if you take Snowflake with an Azure, we will give you this discount. Okay, now if you want to go with an AWS, if you believe that AWS is going to have a high encryption in the market and there is no data leaks happen, they maintains very well in that cases. If you want to go with this one, you will be getting this much discount for a 10 years. Okay, so they say pros and cons. Okay, how the pros and cons is latency, cost, availability, backup, how disaster can be activated. Okay, how the services will be maintained in a company, how hard for them to maintain the infrastructure for a cloud services. So what is AWS? These guys are, we are talking about, these three guys are the cloud service providers. What is cloud service providers in sense? These guys will be maintaining all the infra. If I say they are maintaining all the infra, means they will be physically maintaining all the infra. Okay, they will have their own buildings, they will have their own servers, they will have their own people to maintain it, they will have their own data centers, water, electricity, everything will be there. Okay, these guys will maintain everything and providing their services to the cloud Snowflake. Okay, these guys will charge Snowflake also, saying that while you are using that services. Okay, so your decision which account to be taken is something will depend on the how company really wants the data to be available, from which country they're operating this particular Snowflake account. Okay, so what will happen when you choose your account, right? So when we are also creating an account, it will ask us from which country you're accessing it. Okay, if I select it as in a Singapore zone, so automatically Snowflake has an intelligence to understand, okay, he chose the AWS account Singapore. Okay, now it says that, okay, in Singapore, these are the particular reasons are available. In these reasons, okay, I will be taking this as a main reason, this is as a backup reason. So it have its own intelligence of applying this all. You won't be having any option of choosing that. Okay, you can choose an account on which cloud you want to do it and which reason you want to do it. Okay, so it automatically understand what exactly it should be done. Okay, Snowflake has a private connect also. That is nothing but a company who are looking to have not to have this kind of any network over network. It not happen. That is over internet. If they don't want it, they really wanted a separate line. So now example, there will be companies like London Stock Exchange is one of the major company which is using a Snowflake in a UK. Okay, so now their data is so sensitive whenever they're releasing the prices, market prices, how it is changing. Okay, those companies, what they do is they will go with the private networks. So how this private networks will work is they will have a separate cable, separate wires. Okay, they will have a separate wires from a company to Snowflake maintaining infrastructure maintaining. Say Snowflake means Snowflake integrated with AWS. Example, it is AWS or GCP and Azure, right? With the data centers, the wire will pass. So when I say wire, it's a literal wire. Okay, wire will pass. Over that wire only all these particular transactions will be happening. Either you're retrieving a data, either in something is happening, right? It's a private network. Okay, that private network will happen, and VPNs also will be created. It's not always a wire. VPNs will be created, firewalls will be created. Using that VPNs and firewalls, you have a different setup. They will be doing it. So when you go for the private networks, it will be more cost for us. Okay, we will see that what are all the options we are having with the Snowflake probably in the next slides. Okay, I'll quickly take this example, the questions. Okay, then what is this? So instead of on-prem through Python, can I deploy through DBT any such solution, or what is the transform layer in a or for a Snowflake? So instead of a Python, right? So you have a different other tools, Karthik. Okay, so there are Python is there, Metallion is there. So you can go with the different tools are available. Click replicate is there, Cognos is there. What you can do is this are all will replicate a data now. Okay, so now example I would say for this, right? So now we are all moving cloud, right? So we are all moving cloud. So our main motto of the cloud is, right? So what happens is every applications, okay, every application wants to run from a cloud. Okay, it could be any cloud. Okay, this is the ideology of the companies right now, right? So they wants to move everything to the clouds. Okay, so once they process something, okay, so example on AWS, let's take AWS, your website is running. Okay, so this website every day you are going to get any hits. That means someone is visiting that website. Based on that, whoever is visiting, those people get been cornered, spotted, and your agents has to contact them. Okay, so this is an ideology of your company. Okay, you have created a website. The people who are visiting that website, that information to be gathered, and you will be passing it to your agents to talk to that customer, say that what exactly you needed. We will all give you this offers and all for you. Okay, this is your thing. Your website is being done on website, on an AWS. Now, what happens is once you have it, your application on your AWS, where the data exactly comes and stores. Okay, they will not go. They will not go back to on-premise, okay, MySQL or a PostgreSQL, or they won't go in on that. Okay, what they do is they will store the data on a cloud only. Okay, they store the data on a cloud only, right? So when you store this data on a cloud, so what happens is now I'm saying your Snowflake can able to connect to any clouds. Okay, at what reason I have told you the Python. Okay, so what happens is till now, right, from few of the decades, what is happening is we've started storing all our data in on-prem because we don't had in cloud something before, right? So this is all your history data. Okay, in migrations, when the migrations is happening, what will happen is you need some communicator in between to bring your data on-premises data to your cloud. That is like example I'm saying it's a Snowflake here, right? So you have to bring this history data to be available in your Snowflake. Okay, so how can you bring that? That's one tool I would say is a Python is a good thing because we are going to learn a programming. So you can use a Python to connect your on-premises, bringing back into your Snowflake. Okay, so it's not mandate. It's not mandate always it should be a Python. Okay, if companies are rich enough, right? If company Python, who needs to write? Developers has to write this code. Okay, developers has to write this code to run this Python. You need a server to be available in your company. This all to be done. What happens is now there are plenty of third-party tools are available. Okay, tools like Click Replicate. Okay, Fivetran. Okay, so you have many others like this. right? So many other tools are there in the market. Okay, what this guy says that, see, take a license with us, you can connect your on-premises, okay, and you can connect your Snowflake. We will read all the history data and we will be pushing it into a Snowflake. Okay, but you have to pay money for us. Okay, which is a license cost for you. Okay, so this is very easy. This is something which is called as in a plug and play. All you need to do is you will be providing your MySQL connection details to this one, selecting what table you have to replicate, and you will be giving your target as a Snowflake, and you will be clicking run button. Okay, so that all your data will be flowing here. There is no learning path on this one. This is, they have already built what needs to be built. Okay, if company is rich enough, they can go for here. Okay, but what I am saying is, for our purpose, for learning purpose, we will design that as in a Python program to read it from an on-premise and put it into Snowflake. Okay, this is again company's decision. Okay, this is company's decision, they can able to take it. So DBT, right? You asked DBT. DBT is a transformation tool. Okay, so in first, your question is in Snowflake where I can run this transformations, right? In Snowflake, you can run these transformations by creating a stored procedures, functions, and all. Okay, so you will be creating stored procedures, functions. So how you can able to transform the data? So example, you have to capture a CDC, which is a change data capture. Okay, we will be using a streams. Okay, and once the raw data is available, you want to turn up into a different transformation with some SQL queries. You can have that SQL queries written, and you can make sure that query is being executed by using a tasks. Okay, so these are all the places where you will be applying a transformations. Okay, no, Krishna, I don't want to do it on a Snowflake, these transformations. What you can do is you can do all those transformations on a DBT and you start loading the data into your different tables. Okay, you can do your transformations on a DBT and you can do it your transformations on a Snowflake also. Okay, does that make sense, Karthik? Can it be Informatica as well? Yeah, can it be Informatica as well? It could be Informatica, it could be NiFi, it could be Data Stage, it could be in Ab initio, it could be any tools which are licensed tools where you have to pay money. Okay, so this, why Informatica? This is something. So example, now I want to remove the duplicates. So what happens is I have to write my own logic to run the duplicates. But when you go to Informatica or Ab initio or somewhere where you have to use just a dedupe components, so you need to select which column you have to remove the duplicates. So it will perform that activity. Okay, so we will be learning in detail of that. Okay, but let me go a little up and see. Okay, Karthi, then why do we have a Snowflake CLI? Snowflake CLI is a SnowSQL. Okay, SnowSQL, it will be communicating with your local machine. That is like whatever is available on your local. That is like in a hard drive, H drives or something, right? Manually, if you want to push some files into a Snowflake for processing, SnowSQL will be helpful for you. Okay, Snowflake CLI, if you want to, whoever is comfortable within some kind of Unix commands to be executed, for those people, Snowflake CLI will be helpful. Okay, if not, people are comfortable with the SQL, they can run the SQL. People who are comfortable with the programming of a Python, they can do with it. Okay, not only Python, there are different other languages like Scala, or you can Spark, Scala, Node.js, Java, anything, any language you can write to communicate with the Snowflake, and you can able to do the tasks. Okay, Snowflake is a SaaS, and AWS could be AWS have all the services. Okay, AWS have IaaS, SSAS, PaaS, data as a structure. Sorry, what is- Just a minute. Who is that? Okay, so let me complete these questions quickly, and I'll come up with the questions. Okay. Yeah, thanks. Okay, understood. Can we use the DBT with Redshift as well? Yes, Rupesh, DBT. So Redshift is also one of the adopter for the DBT. Yes, you can able to connect to Redshift. Okay, data is stored in Snowflake or AWS, Mathu, right? So Mathu, back to the same question, right? So this one. Okay, so now this one. So where the data is stored in a Snowflake or AWS. Now I would say Snowflake doesn't have any storage. Okay, no compute, no storage. Okay, no compute, no storage. Actually your data will stored inside an AWS, but Snowflake will never tell you that it is stored in an AWS. Okay, it always says that you talk to me. You forget that where your data is stored. Anyway, you cannot able to access the data directly from here because it's maintaining by me. I only will have any permissions to it. Okay, so if you need some data, what you need to do is tell me that I need this particular data. I'll bring this data for you somehow. Okay, where I am storing the data, how I am storing the data is something you don't need to worry about it. You don't need to think about maintenance. You concentrate on your business. That's the model the Snowflake comes with.
Okay, so in this case, it will be considered as a middleware, right? The Snowflake considers a middleware between the application, the organization, and the cloud provider, right?
You can consider that way. Yes.
Yeah.
Okay. Why we need a transformation, Azure? So why we need a transformation, right? So Azure, you are from MySQL batch only, right? Right. So Azure, so think that company have some decisions. So we were been discussing one of the concept, right? Companies always comes within a discounts based on some price, right? So you are a value customer to me. So to you, I have to apply some kind of discount in this particular time. Okay. So then that is a transformation, right? So you have some data available, but you are making you are changing the shape of the data to a different, you are deriving the data for a different column. Okay. So in that cases, you have to write in some logic. That logic is nothing but called as in a transformations. Okay. So don't worry, the transformation is not a different language or something. Transformation is nothing but whatever the raw data you are going to get, how you are utilizing that raw data to changing it as useful information. That useful information is nothing but how can you change that into useful information is by applying the logics. That logic is nothing but a transformation. Okay. Okay. Now I think I'll stop going further. I'll take up if there are any questions.
Krishna, Ashwanya,
Yeah,
my scenario is we have an on-prem database which is for the application purpose, and it keeps on updating daily basis.
Okay.
So, and we would be using Snowflakes as a data warehouse purpose. So using Python, we can capture all the data, right? The historical data and the daily changes.
Yes, we can capture it. So,
okay.
So usually what happens is the company's plan will be like this. Okay. Going forward, all my applications should run and store data into cloud. Okay. This is what their vision going forward. Their vision is this one. Okay. So what happened is, unfortunately, before we didn't had a cloud, so they have been started storing the data into an on-prem. Okay. So what happened is the migration is happening. Migration is happening to cloud. That's a Snowflake cloud. Okay. So what happened is here it is an everyday transactions is happening. Okay. Everyday transactions are happening. Okay. So what happened is, first thing, how they need to come up with a solution. This is a very, very common project in all the companies. Okay. So you go to any company, this project would be there. Either they would have implemented it, either it would have been running already. Okay. So what happened is, first thing is they want to move all the history data. Okay. They'll move all the history data into Snowflake by some means. It can be a Python, it can be a third-party tools, which I discussed about. Third-party tools, right? So third-party tools, they will use this they will use this thing, they will move all the history data into Snowflake. Okay. So what happened is, while they're doing this migration, still the applications are running and started capturing the information over here. Okay. What they do is they will put a particular point in time saying that by this January, we have to move everything, and applications which are loading the data into an on-premises have to point it after January. This all started pointing to Snowflake and start loading the data directly into Snowflake. No more on-prem. Okay. So what happened is, but till that point in time, how you are going to capture that everyday running transactions are a delta data. We call it as a delta data. Okay. So this delta data, what will happen is, every day they will be writing a Python. They will understand saying that read all data belongs to yesterday only. Okay. What are the transactions happened yesterday? Read that data and start loading into Snowflake. Okay. But once at a particular point, once they reach to the February, after January, the February 1st onwards, their applications will start injecting the data into an on-prem. Directly, they will be injecting the data into Snowflake. That's their idea of a long term. Okay. So, but on-premises, if it is happening, your Python, we will be designing a program in a Python and saying that what are all the transactions is being stored inside that particular yesterday's batch. So read the data and put it into Snowflake. Okay. We will be writing that. But your end goal should be this one. You cannot have your on-prem and a Snowflake. Both is not needed for your company. Okay. The company will slowly decommission this one. They will be moving totally into your Snowflake. Okay. Does that make sense?
Yeah, yes, Krishna. But the plan is to continue with the on-prem for the transactional purpose and use Snowflake for the analytical purpose.
Yeah. So in that cases, they need to have this medium forever. Okay. So what they will be doing is, in this example, I'll give you an Oracle. Okay. So what happens is in Oracle, you will be having ODS data, which is operational data systems. Okay. Okay, operational data systems are will be available. Right here, you will be capturing all your operational data. This is OLTP data will be there. And finally, they want to store this instead of they storing this analyticals also on this on-prem, they will be moving all the analyticals into your Snowflake. And they will be capturing all the OLTPs inside an Oracle, and they will be moving into Snowflake all their analyticals. Okay, so you can have a design like this also. It's up to them. Okay, so it's not like they cannot maintain this particular Oracle ODS on this Snowflake. They can maintain it, but they thought like probably it's not a constrained database. That we will discuss it tomorrow. They want to still stick to the on-premise. It's up to them. It's up to the company. Oracle will be already there. They have a license for next 2-3 years or 4 years or something like that. Why to waste that money? So they will be extending their Oracle for some more time and doing their activities on it. It could be possible. It's up to the company again. Does that make sense? Did I answer your question?
Yes, Krishna.
Okay. Yeah. Any other questions?
I have a question. So you did mention there is no compute, right?
Yeah.
And you also mentioned this is pay as you use it.
Yes.
So doesn't it like the payment, the credits? Because I have just downloaded it. So just wanted to know, based on the query execution and like the operations what we perform, is that the compute cost work? Like what exactly it means when you say no
how much
compute?
time this query is going to run for you, how much data it is going to read, how much time it is going to run this particular servers for you. Okay, that is equals to is nothing but your billing. That's a cost. Okay, so but it doesn't mean the cost we are paying it to the Snowflake. Okay, as a customer, I am paying it to the Snowflake because I'm using this particular, I'm querying on Snowflake. Okay, I'm responsible for a Snowflake to pay it. But internally architecture, if you want to, if you're understanding it, is Snowflake really providing this computer storage? No. What happens is Snowflake will leverages AWS services, infrastructure services and everything, and it makes sure this computer and the storage is available for us. Okay. So if I pay to Snowflake, Snowflake will pay to AWS. Okay. So when Snowflake provisioning or onboarding the infrastructure which needed for this query to be executed, so that it will be all maintained by a Snowflake in an optimized way. Okay, does that make sense?
Okay, so then one more question. So I think it's a couple of days back we discussed about the staging, and you did mention about three levels of staging.
Yeah, medallion.
When the data comes, right. So what happens when in that, like there also the data is coming and you're not storing it? It is again in AWS is where this happens.
Whatever you store it on a Snowflake, right? So when whatever is the table, the customer table, the example thing that this is a staging layer. Okay, I'm going to store the data here. Okay, that means this data is storing here only. It is just by looks on a look level. The top layer you will be able to see. The bottom layer you never know. Okay, still it stores in a AWS only. Okay, everything, right? Everything gets stored in an AWS in a bank. So whatever the cloud, okay, I'm not stressing on AWS here. Whatever the cloud you choose it, okay, it will be storing there only. On a cream layer, on a top layer, what will happen is you will be understanding it is in a Snowflake is storing it. Okay, because to you the Snowflake is responsible to provide the data back. Make sense?
Okay.
Why there is no other cloud provider other than 3 listed, or can I have the privileges to see my own storage, even be it even local on-prem? So yeah, so Karthik, so the expansion is happened only to the 3 clouds. So there is an OCA Oracle, Oracle Cloud Connector, right? So so Oracle Cloud Connector, Alibaba is there, IBM is there. Okay, so right now Snowflake has been expanded their services only with the 3 public clouds, which is a major of the markets. Okay, major of the markets. You can take almost 65% of the market in the cloud has been captured by these 3 guys. Okay, so they extended that, they tagged with those them. So eventually they will be coming up with the OCA also. Now Oracle is little bit booming. So probably I would call 3 to 4% is there. Okay, so where AWS is almost within a 38% in the global, right? So eventually they might come up. So right now the services is provided only with these 3 clouds. So in by that means any services, right? Any company, you take the services which they expanded the services, their company information is only with these 3 services, very less with the other cloud services. Okay, eventually probably in the market they might come in. Okay, Can you please share the details of shared disk architecture and shared nothing? Yes, Ganesh, we will be discussing this, shared disk architecture and shared nothing architecture when we are learning about a warehouses. Probably it's a second or third class we have it. There we will learn. Okay, I believe Snowflake multi-cluster architecture evolves from that. What significance changed from the previous architecture? Yes, we will be shared nothing architecture, shared disk architecture, single disk architecture also. These three we will be showing. We have a diagram also for that. Okay.
Okay, Krishna. Thank you. Thanks.
In that case, what will happen on autonomous cloud or Snowflake? So what will happen in sense? What exactly your question here, Karthik? Karthik, I didn't get you. In that case, hosting. Hosting is going to be again. So Snowflake is a master who plays with an Oracle in case if that comes, like how it is dealing with an AWS right now, right? So Snowflake will start leveraging the infra of all this Oracle, and the Snowflake will create its own intelligence of working with an Oracle. License and all, Oracle license and all, we don't need to worry about it. Snowflake will look after this license and everything. While we are creating an account with a Snowflake, so Snowflake says that I want my data to be stored in an Oracle. Use the Oracle cloud for me. Okay. So in that cases, you will be choosing it. All the licensing costs, maintaining the infrastructure, everything will be maintained by an Oracle. Okay. Then we have to see that how much it's not only storage, it could be in compute instances also. It might be utilizing that. Okay. Load balancers, compute instances, everything will be utilizing it. Okay. So how backend they are running it, but we have to see how much cost they will do it. Okay. It's all negotiations, how, Oracle is going to talk with Snowflake, how really they are going to reduce the storage. Now Snowflake will declare saying that, okay, better than AWS in this particular. Oracle is not there in a multiple reasons. Okay. So probably India or some places, Australia and all it is there. I don't think so in Sweden, in that snowy areas and all they have, because it's very hard to maintain the infrastructure in that areas. You have to spend a lot of money over there. Okay. So Oracle is not yet expanded to that areas, I believe, for now. Okay. So what happens is now you have to go with the negotiations. It's just an agreement happens between Oracle and Snowflake, right? Then if really they give good at the particular location, Snowflake says that in this particular location, Oracle is giving, very best in cost comparing to the other clouds. Why can't you take an Oracle? So they come up with suggestions. Okay. So now Snowflake becomes like a consultancy also when we are going with an agreement with them. They say that, okay, you work with this, you do this one, we will give you a best cost. Make sense? Any other questions, Karthik? I just want to show one thing. Yeah, here it is not there. Okay. This one also I want to show. Someone asked ETL, ELT, right? So we'll continue this tomorrow. We don't need to rush this one. Okay. So whenever we creating an account, right? So people who are wants to, I don't say don't create it right now because it is only for 30 days. Okay. After 30 days, your account is going to be expired. Okay. Don't rush of creating it. When the first class starts, first understand the architecture, how it works. Then when first class starts, we'll create it. Okay. So it expires within 30 days. If it expires, right, you can create in another account within a different, with a different email address, create a dummy email address and create a one more account. It's a free of cost. Okay. You don't need to tag your credit cards or anything. Nothing is needed. Okay. All it needs is one email address, new email address. Okay. You can create it. So whatever we are practicing on this month, start saving that scripts. Either it is a creating tables or whatever it is, right? So we will go into, in case if your account get expired, we will going to use that scripts to recreate that into a different account. Okay. So anybody wants to create it for now or have a look of how it needs to be created, you can go into Snowflake trial account creation in Google. So it will go there. So don't continue it. So just have a look what or not it is going to be providing for you. Okay. But Oracle has own reporting analytics. So if storage is offered, then why will Oracle go for a Snowflake rather than autonomous cloud? But by Snowflake. Thank you for this. Yeah. So Oracle is going. So then why will Oracle go for a Snowflake? So Oracle go for a Snowflake. So why will is cost optimizations, right? So if you have it now, the same question you would have been asked. AWS also have all the reportings, analytics is there. QuickSight is there. There are multiple other analytical tools is that in BigQuery, in GCP, BigQuery is there, Looker is also there. So why can't they go there, right? So again, back to the point is, you have to take care of more of optimizations implementing on those clouds. They will say that there is a service available, design yourself. That means you need an extra developer who has to design it in an optimized way. But Snowflake says that you get rid of that particular resource. I will provide you the optimizer. Okay. I'll give you optimized solution already, which is available for me. So instead of you spending money and managing that particular resource, what I will be doing is with the software which I already created, you can use the software for that. Okay, so that you can put your concentrate more on a business instead of you making some corrections and building something. Okay, and one more thing is cost thing, right? So Snowflakes, so optimize this example, I would say that on a Snowflake level, so on an Oracle level or an AWS level, how you are going to store the data, right? So once you store the data, how you are encrypting, re-encrypting the data, compressing the data, this all you have to take care by yourself. Okay, so in what fashion you need it? How can you apply the clusterings on top of it? How micro partitions, how can you flush the data which you don't require it? Okay, so how you can able to implement the time travels on this, how you can able to implement the cloning on this. So these all things you have to take care when you go with this own clouds. So they say that these opportunities are there, but you have to develop this. That for future we have to develop in this particular clouds. Okay, where you have to spend your resources to build that particular logics. But Snowflake says that I have already built that all logics. Okay, I'm going to give you this feature. Why can't you simply use it? Why what you are going to spend $100 designing that logic, which I'm giving you for a $10 or $20, which is already available. You don't need a testing for it, which is already tested and readily available to use it. Okay, taking that all into a considerations, then companies decides why they want to go into a Snowflake or whether they want to do it on a AWS. Okay, a simple example is, so you have all the parts available, clouds will be provided for you. You have to assemble your car. Okay, Snowflake says that I'll give you an assembled car. All you need to do is drive. Okay, so now company has to take a decision whether they want to build a car, they want to drive the car. Okay, I hope I made sense. Okay, perfect. Any other questions? Okay, if no questions, we can wrap it up for today. Okay, we'll catch up tomorrow morning.